Hey, so we're going to get into some more stuff about circles and angle measurements and segments and all that kinds of stuff. So what I'm going to recommend to you is to get a compass. If not a compass, then a mug or something round, the bottom of a bowl, something that you can trace, because we'll draw a lot of circles. Use a pencil so that you can, fix anything if you make a mistake, and then make sure you draw each figure accurately. So make sure it matches what I have. And I would recommend drawing it out and then listening to what I have to say afterwards. Alright, so let's go ahead and get started. Section 6, we have secants, and this word is new. Tangents, which is any line that touches a circle at exactly one point, and then their angle measures. So how do they all work together? Well, a secant is a line that touches a circle at exactly 2 points. And a lot of my students in the past have remembered secant 2 because of the word second, so S-E-C, same as secant. So second and second meaning 2, so they could kind of remember that. Also, a lot of you may be wondering, okay, well then how is that any different from a chord? Well, remember that a chord has its endpoints on the circle. So a portion of a secant is a chord, but a secant can keep on going and extending outside the circle, which a chord does not do. Okay? So let's go ahead and start with secants and arc degree measures, and how are they related? Well, when you're looking at two secants inside a circle, you have two sets of vertical angles. Alright, so angle 1 and angle 2. You have this set, those are congruent, and then you've got this set here, alright, that are congruent as well. And even if you wanted to, you can mark them 1, 1, and 2, 2. And what's actually kind of cool about this, and I'm not really sure I know why this works, it might be a little project for me to look up, but if you take both arcs that are formed by the vertical angles, so in this case for angle 1, it's formed by arc AB, and also it forms arc DC. Okay, so if you add those two together and then divide by 2, you will get each of these measures. Remember, they are the same. So we take, to get the measure of angle 1, we take our arc AB, add to that arc DC, and then divide that by 2. Pretty cool, huh? So we're just taking half of both of them. And now, of course, the same thing works on our other side for our angles here and here. We take the measure of angle 2, and that would be equal to arc AD plus arc BC divided by 2. Now remember that that's angle 2, meaning this angle 2 and this angle 2. Same with angle 1. It's both of these. Okay? And also keep in mind that 1 and 2 are supplementary, because that may be helpful sometimes, because maybe you have the information to get this angle but not enough to get this one. Well, if you have these arcs, top and bottom, you can find this angle, and then this one is supplementary to it. So you will be using some of that older vocabulary as well. Wrong way, sorry. Okay, now if you have a tangent and a secant intersect, now this is only when their intersection is the point of tangency. Okay, very important that you remember that. W in this case is point of tangency. So remember, we're talking about angles. This is exactly like an inscribed angle. So remember how an inscribed angle is half of the arc that it forms? This is exactly the same. So if you wanted the measure of angle XWV, it is exactly half of arc WV. Cool, right? And then this side would be supplementary to that. Whoa, amazing. And let's say I'm going to add in U right here, and if you wanted the measure of ZWV, that angle, that would be equal to half of arc WUV. And remember, I'd use 3 letters because it's a major arc, so I want you to know that you need to go around the bigger side following those letters. So that's it. It's just like an inscribed angle. It's not even anything confusing or tough. Also remember that these angles here and here are supplementary, so those will be a total of 180 degrees together, so you could find one and then subtract it from 180 to get the other. When this secant is drawn, it splits the circle into two arcs. Now they aren't congruent arcs, but we do know that there's 360 degrees in a circle. So if you knew the degree measurement of this arc, you could subtract that from 360 and get the degree measurement of this arc over here. Isn't it crazy how this all just works? Okay, so what if a tangent and a secant intersect, but this time not at the point of tangency? So outside, maybe that might be important. Add that outside the circle. Okay, so this is when they intersect outside the circle, which would make sense because a tangent cannot go inside, so its only option is outside. Well, what you notice happens when those two intersect is that there's an arc formed right here, as well as an arc that is formed by the same two lines up here. All right? Now, if you look back at this first example that we did, the angles were on the inside of the circle, we added and divided by 2. But now we're doing the exact opposite. Wrong way again, dang it. Now we're doing the opposite where we have the angle on the outside, out here. Well, if we're looking for the measure of angle QPN, what we would do is take our larger arc, so that arc TR, so arc TR, and we subtract RN, that arc, and divide that by 2. So what you'll notice is when they're intersecting inside, we add it and divide it by 2. Outside is the opposite, and we're subtracting and dividing by 2. It's pretty simple. Okay, now what if two secants intersect outside the circle? So now we've got two secants outside, and you'll notice their intersection is right here. Well, guess what? It's the exact same thing. So you're looking at the exact same thing as our last example. You'll see that the two arcs that are in between the two secants, so this one, and then our smaller one right here, and it's on the outside. So if we wanted the measure of angle FHK, that would equal our larger arc, which is FL, minus our smaller arc, which is GK, and then dividing that by 2. And then we would get our angle out here. So remember, it's always the two arcs that are in between the two lines. And again, if we look back at this one, they were the two arcs here and here, not this arc on the outside. Okay? And now we have two tangents intersecting outside of the circle. So remember that ice cream cone thing I was telling you about? Are you going to be shocked when I tell you that we're going to subtract and divide by 2? No, of course not, because we have two lines that are forming two different arcs. All right, so we have the top one up here. And now this one's our major arc. And we're going to subtract from it our minor arc right here. Whoa, sorry, that did not trace at all. My bad. So there we go. See how it's split into two separate sections? Well, outside means subtract. So if we wanted the measure of angle MNQ, that would be equal to our larger arc, so MRQ, and it's an arc, minus the small one, MQ, divided by 2. So major minus minor divided by 2. And that'll give you your angle. I truly have no idea why it works, but it does. And it is just so nifty. Okay, section 7. So that's it for section 6. It's all about the different types of lines and their angles that are made. All right, but now with section 7, we're getting into the segments. So not the angle relationships, but the actual segment relationships. So if we have, first thing, two chords intersect in a circle, the products of their parts are equal. Now when I say products, that means multiply of their parts. What are they split into? So what you'll notice is that AC and CD make up all of AD. So if we take the product of its parts, it will be equal to the product of the other one, BC times CE. Those would be equal. And it's one of those things that just works. Alright, now two secants coming from the same exterior point, so you'll notice this point out here is their exterior point. It's going through the circle, touching twice. The only reason I didn't extend it is because we're talking about just these segments, okay? Now this one gets a little bit confusing, and it's more that you forget, not so much that you can't understand, but it is the exterior, which means outside the circle. Okay, so the exterior is the outside portion of the segment. Okay, so outside the circle, multiplied by the whole length. So if we wanted to know how long each of these segments were, either the whole thing or just the portions, you will take WT, which is the exterior, and multiply it by the whole thing, which is VT. And that would be equal to the exterior, UT, times the whole thing, XT. Now one thing to be careful with is that when you are looking at VT, the way that you get that measurement is by adding the two segments together. A lot of times you'll want to multiply them, so be really careful with that. Same with XT, that is really XU plus UT. Okay, so what you need to remember is it's exterior times whole equals exterior times whole. Okay, so this is for secant 1, and this is for, secant 2. Okay? So I promise that we'll have a lot of practice with this because I know that it's a lot. Now if you have a tangent and a secant coming from the same exterior point, remember in the last one the secant was exterior times the whole? It is exactly the same. That is exactly the same, but with a tangent what you'll actually do is square it. So you'll take CE and you will square that measurement, and that will be equal to your exterior, CV, times the length of the whole thing, CR. And remember that CR is really CV plus VR. Okay? We're getting there, guys. We're almost done. Okay, so let's show you a couple of examples. So this one, we've got a secant here and a tangent. We square the tangent, so x squared, and we set that equal to the outside, which is 5, times the length of the whole thing. Remember, it's portion plus portion. So we get x squared equals 5 times 12. X squared is 60. So we take the square root of both sides and we get x equals the square root of 60. And you are more than welcome to leave it just like that. Two secants, remember it's exterior times whole equals exterior times whole. Okay, so exterior for the first one, I'll do this one in this color, and I'll do the top one in that orange color kind of thing. Alright, so exterior, 6 times the whole thing, which is 6 plus 4, equals exterior of our second one, which is 5, times the length of the whole thing, 5 plus x. This part right here is where you're going to start to get confused or just make mistakes. You'll put 5x instead of 5 plus x. Alright, now we solve it from here and go on and on and on. Now with these two over here, two chords, 6 times 2, two portions of 1, multiplied by, or equals 3 times 4. And you notice you get the same product. Alright, I don't have much time for music, but you better believe you're going to get it anyway. Dance, you're done.
TikTok. touch this.